Hello students, the next question is 79 of the waves and sound. Sonometer wire. Sonometer is a device, mechanical device. It contains a wire fixed on the two triangular shaped bridges which are kept on the hollow box. This hollow box contains a hole so that air can vibrate in and out. This wire is taken out of the pulley and load is suspended here. Load is capital MG we take. And wire mass is M, total length is L. Can be divided into parts. This is L1, L2, L3. This L1, L2, whatever the L you are taking, sorry, you take it as L, L1, L2. This L length between these two bridges is one we are going generally use for the practical experiment purposes. Sometimes they will give you the ratio of the lengths. The frequency is inversely proportional to length of the wires. In the wires, the waves, wire has the waves, transverse waves. But sound you are hearing is through the air is longitudinal waves. But just the distance between these two bridges, the length can be changed, frequency can be also changed. The frequency of the vibrating strings or any frequency V equal to F lambda, F equal to V by lambda, and V is equal to root of T by mu for wires strings into P. P is called as the number of loops we take. So fundamental mode means single loop. Two loops if you get means two loops is corresponding to other than fundamental called as overtones, first overtone, second overtone, and so on. And harmonics, first fundamental itself is called as the first harmonic, and then second harmonic, third harmonic, onwards. Harmonic number itself is a number of loops, so P is also harmonic number we can take. Overtones other than fundamental are called the overtones, higher frequencies than the fundamental, multiples of the fundamentals. As a overtone number increases, the number of loops increases, amplitude goes on decreasing. Same length of the wire we are taking for the comparison purposes. So this formula is important for the vibration of the strings. This mu is called as the linear density. T is a tension. Tension itself is mg. This is T is weight you are hanging. If you are putting in the water or liquids, then apparent weight you is equals to actual weight in the air into 1 minus density of this solid by density of the liquid we are putting in by density of the solid you have to use if it is immersed in the water. This itself becomes equal to new tension of the wires. The weight itself is a tension. This itself is a tension in the wire is T, and number of loops. Fundamental mode means P is equals to 1 we have to take. So F equal to 1 by 2L it becomes. And frequency ratio for the strings is 1:2:3 related to the number of loops. Also you can take 1 loop, 2 loop, 3 loops also. You can take our harmonic number. These are all harmonics are present in the vibrating strings. Always at the closer end node is obtained, at the free end antinode is obtained. Difference between the two successive overtones or harmonics is equal to fundamental. This point is also important for that. Fundamental frequency is V by 2L. You are in this problem, they are given that the difference between the successive frequency overtones is 150 Hertz they have given. They are asked to find out what is the first overtone. Fundamental frequency is nothing but equal to V by 2L is equals to 150 Hertz they have given. This is equals to difference between the two successive frequencies. So overtone is nothing but equal to first overtone is a fundamental, first harmonic, second harmonic, third harmonic. After leaving the fundamental, remaining are overtones. First overtone, second overtone, third overtone, like that you have to take. So overtone number is one more than that of the harmonic. Second harmonic means first overtone. One overtone number is one less than that of the harmonic numbers. So we are taking the first overtone they asked. First overtone means 2 times fundamental, 2 times this F naught. So this F naught itself is 150 Hertz. So 2 into 150 is 300 Hertz is the first overtone. Next 80th question. Sonometer wire. Length is 1 meter. Mass of the wire is 4 grams. Converted to kgs, and tension is given is equals to 2 kg weight. Means 2 into small g, acceleration to gravity is the tension you can take. So tension is equals to 2 into g, 19.6 newtons. And this linear density mu is equals to mass by length. To avoid the confusion, M naught I have taken for the wire by its length. Length is equals to 1 meters. So this mass by length is equals to linear density. By substitution you will get the expression velocity of the wave they asked is root of V equal to 70 meters per second. V depends on the tension and linear density. Linear density is mass by length. Heavy ropes if you take mass is more means velocity is less, and vice versa. More tension, more speed of the wires. Tension means tightness of the wires. Next, two waves. Question number 91. Two waves of the wavelength lambda 1 is 2 meters, lambda 2 is 2.02 meters produce 2 beats per second. 2 beats per second, and velocity of the wave is how much? Here number of beats per second. If whenever the two tuning forks or two sound frequencies are produced, if they are mixed up, one frequency is F1, other frequency is F2. Whenever these two are mixed up, the resultant wave will have the amplitude changing from between the maximum and minimum. Minimum can be 0 also, depending on these amplitudes. So this maxima and minima together is called as 1 beat. This maxima and minima between these two you can take, but maxima plus minima becomes equal to 1 beat. Number of beats per second is equals to difference of the two frequencies. Number of beats per second is difference of the two frequencies. Per second, if they give per minute, convert into per second. And difference means we have to subtract lower one from the higher one always for the difference of frequencies. You have to take a maximum number of beats a human here can detect is 10. If the number of beats is more than 10, this one beats like this, if more than 10 are there means we can hear only up to 10, but if the frequency is more than, beat frequency is more than 10 means that sound is heard as a continuous sound but not as a gap is there means we hear that as a beats. So number of beats maximum human being can detect is 10. If they are more than 10, 100 is a frequency difference is there means what is the number of beats heard means you have tried 0. We cannot hear the sound as a beat, so we hear it as a continuous sound. Up to 2, 3, 4, up to 10 only the human ear can detect the maximum number of beats. Next is the difference in frequencies is equals to number of beats per second is given as a 2. So delta f is equals to 2, but v equal to f lambda, f equal to v by lambda. F1 is v by lambda 1, f2 is v by lambda 2. We take out common 1 by lambda 1 minus 1 by lambda 2, substitute this lambda 1, lambda 2. You will get the difference in frequencies as 2. By solving this, you will get the velocity of the sound as 404 meters per second. Next question number 92. Natural frequency tuning fork is given 432 Hertz. And Q is unknown frequency. Whenever the P and Q are sounded together, 3 beats per second are produced. Two frequencies are mixed up to get the resultant beat called the 3 beat resultant frequency with the variation of the amplitudes between maximum and minima. And how many beats are heard is 3 beats per second. But in this case, there is no guarantee that P is more than Q. We can take PQ minus P, PQ minus Q. Both are difference is equals to 3. We have to identify which is correct in this. Next, the second case, what is done is P is waxed. Wax means some load is kept on this tuning fork prongs. Whenever the mass increases, the frequency decreases. So in this case, by waxing, P is waxed so that the frequency of the P decreases. Frequency D decreases. So new frequency is P prime is less than P. Now again you are sounding with the Q. The number of beats produced is 5. So P prime can be more than Q or can be less than Q. But by loading this wax, frequency decreases. When this value is less, Q minus P will be increasing here from 3 to 4. That means this is possible that P is less than Q. P is less than Q means among these two choices we have to take Q minus P. P minus Q means P is greater than Q. P is less than Q only, we can take Q minus P. Therefore, the choice is this one you have to prefer. In this case, we have to find out P is given, you have to find out Q now. So, Q minus P equal to 3. So, Q equal to P plus 3. P is 432 plus 3 is equals to 435 is the answer. In this, we may be given the filing also. Filing means rubbing with the rough rod. That rough rod is called as a file. So filing means rubbing of the material. When you are rubbing of the material of this tuning fork prongs, the material decreases, means mass decreases. In that case, frequency increases. I gave the example of frequency decreasing. Similarly, you go for the frequency increasing also. And instead of the P waxed, sometimes they may give for the P filed or Q filed or Q waxed also they may give. Next, 98th question. 98. Tonometer. Tonometer contains multiple tuning forks fixed side by side. And with this constant difference of the frequencies. Difference of the frequency is constant, that is nothing but equal to beat frequency. You will get number of beats per second. So when two are sounded together like this, if you keep on hitting it, the frequency is not constant. Frequency, this is the lowest means frequency gradually increases, or if it is highest means frequency gradually decreases. By hitting them, you can hear the musical sounds. So the relation between them is maximum frequency equal to minimum frequency plus. If this is a minimum, this is a maximum. So minimum frequency plus n minus 1 into delta f. Delta f is the difference of frequency, that is number of beats per second. N is the number of tuning forks and n minus 1 you have to take 1 less because the gap you are taking is 2 equal to 1 you have to take. Gap is only indicating the number of beats per second. F max equal to f minimum plus n minus 1 into delta f. In this question they gave number of tuning forks is 25. So 25 minus 1 is 24 you will have. And you are given that one frequency, maximum frequency is given as 288. They asked you have to find out what is the lowest frequency in the tonometer tuning forks list in the order. So this maximum is equals to f minimum you have to find out 25 minus 1 into 4. Calculation you will give minimum frequency is 192. In reverse also they may ask, they give the minimum, they may ask maximum, or they may ask Mostly they ask like that only, but rarely asked is delta F calculation at bit frequencies. Next question number 1 or 2. A car is approaching mountain with velocity 90 km per hour. Sound speed is 335 meter per second. This will be given as a source of the sound Vs, and this as a velocity of the sound as Vs, velocity of the car is Vc, also symbols we can take. I am giving the speed of the sound 335 meter per second symbol as a C. And horn produces sound and hear the echo after 4 seconds. What is echo? If you are shouting near the tall buildings or a mountain, sound goes and comes back, that is called as the echo. And what is the minimum distance to hear the echo is 17 meters, 16.9 is approximately 17 meters. This is a D. Sound is going with the speed V. It is not a velocity, please, speed it is. So don't take the displacement, you take the distance. While going distance is D, while coming back distance is D. So total distance traveled is 2D. Speed is equals to 2D by T. Then time to hear the echo. If you want to distinguish the two sounds, in the small rooms you don't hear the echo, but you will hear the reverberation. Reverberation is not in the syllabus actually, but we will discuss later. So if you are here, the distance is large enough, means sound goes and comes back. Direct sound from the mouth to ear and reflected sound. Time difference is required. The time difference is related to the perception of the hearing is 1/10 of a second, equal to 0.1 seconds. If the time interval when the two sounds is equals to 0.1 second, then our eardrum can detect the two sounds as the different sounds. So that is called the perception of the hearing is equals to 0.1 second. So minimum distance to hear the echo D is equals to Vt by 2, and velocity of the sound depending on this, that may be 330 meter per second approximately room 0 degree centigrade, or at high temperatures this will be maximum reaching is 350 or 360, do not cross this generally. So substituting these values you want to get minimum distance D is equals to approximately 16.9 meters. So to hear the echo, the distance of the obstacle must be more than or equal to 16.9 meters, approximately 17 meters. And if the multiple reflecting surfaces are there, if you are shouting between the two hills, then sound goes and comes back, sound goes and comes back. This is a D1, this is a D1. Distance between the two hills is called as valley. Width also can be found by hearing the time, by finding the time difference between the echoes, first echo and second echo. Total time you can take same principle what I discussed that you have to use here. So velocity is equals to 2D by T is the basic relation for the velocity of the sound. This is the distance travel, this is the time, minimum time related to echo, or whatever the time they give, that you can use this to find the distances. So but here the car is not stationary, it is moving towards a hill, produces sound, and sound goes and comes back. By the time sound comes back, the driver will be hearing the sound here, or already car travels some distance here. In this problem, car is traveling towards the mountain or some tall buildings we can say. So the relation for this distance at which that first echo produces this total distance is D is equals to C plus V car into T by 2, and calculation will give the distance as 720 meters. If it is going away, if the car is going away, in case away means this D becomes equal to C minus V car by 2 into T. In place of plus you just take a minus. That is the relationship required when the car is going away from the mountain. Next question number 99. Tuning force is given of the frequency some unknown values. You have to find out the tuning force frequency. It is kept on the sonometer tape box, and the sonometer contains a wire fixed between the two bridges tightly with the help of the loads, and a small paper piece is kept on this. Whenever this length of the wire is in resonance, means having the unison or resonance with the tuning fork frequency. Whenever the both frequencies matching, then the wire vibrates with the fundamental mode. In the fundamental mode, you will find the maximum wavelength and maximum amplitudes and minimum frequency. That is the fundamental mode. In that case, the string vibrates with maximum amplitude and paper will fall out. That is the condition we taken for the fundamental frequency and resonance we called it. So that sonometer wire has the frequency resonance at for the length L1 equal to 20 centimeters, and frequency of the sonometer wire resonance condition. Resonant frequency is inversely proportional to length of the wire. For the strings, for any strings, force frequency, resonating frequency inversely proportional to length. That is for the fundamental, or any frequency also inversely proportional length. Fundamental we are discussing here. Fundamental coinciding both. Then the frequency, whenever the tuning fork and vibrator strings kept together, they produce the frequency separately. If they vibrated and then tuning fork kept, no, the difference in the frequency they heard is 5 beats per second was heard. Next, what is done is the length of the sonometer wire changed, means distance between the bridges changed to 21 centimeters. First 20, next 21. Then second case again the frequency found out to be 5 beats only. That means what? First frequency of the string was more than the tuning fork frequency by difference of 5. Next, when the length changes, whenever the length changes, frequency decreases. The wire frequency decreases below the tuning fork frequency, and again when they sounded together, the bits are 5. So that means difference remains same in both the cases. In that case, first it was above tuning fork frequency, in second case it is below tuning fork frequency by the difference of 5. So that means the beat frequency first F1 wire, this is a wire and tuning fork, difference is 5. Second case is tuning fork is more than the wire frequency, therefore difference is again 5. Add these two equations. When you add these two, F0 cancels, it is F1 minus F2 equal to 5 plus 5 addition 10 it will get. F1 plus F2 equal to 10, but F is inversely proportional to L. F1 L1 equal to F2 L2 for the strings, and F1 by F2 if you take L2 by L1 is 21 by 20. You will get this F1 from this, you take a 21 by 20 into F2. Put the value in this for the equation F1 minus F2 equal to 10 relationship, and F1 is 21 by 20 into F2 minus F2 equal to 10. Take the LCM of this, 21 minus 20 equal to 200 you will have. 21 minus 20 is nothing but equal to 2, equal to F1 only. So F2 equal to 200 Hertz. This is the wire frequency second case, but we don't want that. What we want is tuning fork frequency. So tuning fork frequency is nothing but equal to F0 equal to F2 plus 5. F2 is 200 plus 5 is 205 Hertz. Next 104. In the 104, this is related to the Doppler effect. So what is Doppler effect is the change in the apparent change. Means apparent change is also called as a pitch. That appears to the person which is hearing the sound is called as a pitch. Also pitch is nothing but the frequency, approximate frequency range of the sound, similar to the color in the light. So in case if the observer or source are moving towards each other or away from each other, then frequency of the sound changes. That apparent frequency is nothing but equal to original frequency into C plus or minus VO by C minus or plus Vs. When they are moving perpendicular to each other, there is no Doppler effect. At some angle if you are taking means cos component of cos value you have to take that V0 or Vs. That you can go to the synopsis. Here basic condition we are taking is same line of motion we are taking. If the observer is at rest, VO is the source of observer velocity. If the observer is at rest, V0 is 0. If the source is at rest, Vs is 0. If they are approaching, then the observer is approaching the source or source approaching the observer. In that case you have to take a numerator C plus or minus VO. Observer approaching the source, what I get here is plus VO you have to use in the numerator, and going away from the source, observer is going away from the source at rest or not, whatever it is, observer is going away from the source, then you take it as a minus V0. If the source is approaching, observer is at rest, your source velocity is towards the observer, then you have to take this velocity of the source. Observer approaching means always remember whoever is approaching, frequency increases. So approach condition, frequency F prime, this apparent frequency is greater than F, frequency increases, and receding, going away from each other or anyone is going away, the frequency decreases. So frequency increasing, frequency approaching increases, going away decreases, and both are in motion. Both condition you take, that depends on the increasing or decreasing conditions you can take. Here I am discussing is one in motion, one is at rest. So observer source is moving towards observer, frequency increases, then you have to take this denominator as a minus, and observer source is moving away from the observer, frequency should decrease, that means denominator should have the plus. That condition, sign condition you take. This is the general formula for the apparent frequency in the Doppler effect. Doppler effect in the sound is non-symmetric, means while coming and going same velocity also the frequency change is not equal, but in the case of the light speed is very high compared to this observer source velocities. That Doppler effect is symmetrical in the case of light we take. Next, come back to this problem. Observer approaches means coming towards, frequency should increase, so stationary source, so velocity of the source is 0. Apparent frequency is F prime equal to original frequency F into C plus VO by C. Approaching means plus in the numerator, receding means minus V0 you have to take. V0 is observer velocity, Vs is stationary source means Vs is 0. That is not going to be used in the expression. Then formula, you are given that apparent frequency given in this case 505 Hertz, F prime is 505, F you have to find out. And one more condition they have given, that velocity of the observer is 1% of the speed of the sound they give. C is the speed of sound, if you take in 1% means 1 by 100. So C by 100 is nothing but equal to V0. Wherever V0 is there, you can replace with the C by 100. So 505 is equals to F into, this can be written as C by C is 1 plus V0 by C. V0 by C from this expression will get 1 by 100. This is 1 by 100. LCM you take 100 plus 1, 101 by 100. F is equals to Cross multiply this, 505 into 100 by 101, 101 into 5 times is 505, so 5 into 100 is 500 Hertz is the original frequency of the sound. Next question number 109. Question number 109, this train is approaching the stationary observer is at rest, sound is coming, that train is producing the whistling sound and coming and then going, that means observer is at rest, it is approaching and receding. While approaching frequency increases, while receding frequency decreases, but observer velocity is 0 here, observer velocity is 0, so what we take is only source velocities. So while approaching, velocity of the approaching frequency should increase, so minus in the denominator here to take a c minus vs. C is the speed of the sound, c by c minus vs. C is given as 330 meter per second in the problem. While receding frequency, apparent frequency f equal to f prime double prime, I get taken f into c by c plus s, approaching, receding. Here apparent frequency f prime, here apparent frequency is f double prime, original frequency is f or f naught we can take. Taking the ratio of these, you are asked to find out the ratio of the apparent frequency while coming and receding. F prime by f double prime is equal to, if you take no, f is inversely proportional to c minus vs, so you will get is c plus vs by c minus vs. F double prime inversely related to c plus vs. So is c plus vs by c minus vs. C is the speed of sound 330 and source speed is 110. 330 plus 110 by 330 minus 110. This is going to be 440 by 220. This will be 22 2:1 is the answer. Next, 111. And one more condition for the Doppler effect to applicable is that compulsorily speed of the observer is less than the speed of the sound and the speed of the source is compulsorily less than the speed of sound. Otherwise, Doppler effect is not applicable. That is a limitation of the speed of the sound. The limitation of the Doppler effect. Sorry. Next, 111. Minimum distance between the person and wall to hear the echo is 16.75 meters is given. What is the speed of sound? You have to find out. A person is shouting near the wall, sound is going with the speed c and then coming back to the person. After time t seconds he is hearing. Minimum condition if they taken means the perception of the hearing is 1/10 of a second, which is equals to 0.1 seconds. You have to take for the minimum distances. This is for minimum time or minimum distance conditions. So speed is equals to total distance traveled is d plus d by time taken is t. So c equal total distance by time, then total distance is 2d by t, t is 0.1, you have to take for the minimum condition. So calculation will give 335 meters per second. Next, question number 120. Ratio of the intensity of the sound. These similar formulas we will take in this wave optics. Those formulas can be are useful in this case of the sound also. Ratio of the intensity of the sound is given as I1 by I2 is 1 by 16. Intensity is proportional to square of the amplitude. So I1 by I2 is A1 by A2 whole square. It is supposed to be equal to 1 by 16. Taking the root, they are A1 by A2 equal to 1 by root of 1 by 16 is equals to 1 by 4 you will get. Next, 126 question number. Velocity of sound at t degree centigrade is, you have to find out if the velocity of sound at t degree centigrade is one third of the velocity at 0 degree centigrade. What is the temperature they ask T? So velocity of T is small t means centigrade scale, capital T means Kelvin scales, and we know the velocity of sound is proportional to root of absolute temperature. Depends on the RMS velocity of the gas molecules also, which is also proportional to root of T. So velocity of sound is proportional to root of T. This is a sound speed. Previously we have taken the V, different symbols, source and observer. Here there is a speed of sound we have taken as a C there. I am taking here as a V, sound speed, or velocity of sound in air. This is in air, not in the solid and liquids. So in the solid and liquids, the velocity of sound depends on the modulus of velocity and the density of the materials. As the velocity of sound in any metal is equal to under root of elastic modulus E by density of the material. Elastic modulus can be bulk modulus or Young's modulus. And for the gases, this is going to be gamma P by rho. This is the density, P is the pressure, gamma P by rho. And even though mentioned of the pressure is velocity is independent of the pressure place. It depends on density. And pressure PV equal to nRT, we take that relationship. So pressure is the expression in terms of the temperature only. So we'll get V is proportional root of T, but not on P, because pressure increases means given volume of the atmosphere, pressure volume equal to constant. PV equal to nRT condition you would take, and you will get the relation as V is proportional, velocity, it's not volume, is proportional root of T, but independent of the pressure. Careful with that relationship. Coming back to this problem, V is proportional to absolute temperature T, but given temperature centigrade scale you need to calculate. So velocity is Vt by V naught equal to T1 by T naught, 0 degree centigrade plus 273 kelvins. T1 is T degree centigrade plus 273, we have to find out that is equals to given as 1 by 3. square both sides. 1 by 9 equal to T plus 273 by 273, cross multiply that and solve for temperature T. You will get the negative temperature below this. As the temperature increases, velocity increases, but you are asked is the velocity decreasing here. So the temperature will be lower value minus 42.7 degrees centigrade. Next question number 127. Intensity of sound is doubled, they mentioned. Intensity is doubled. When the intensity is doubled, the intensity level changes by what amount? Means I2 is 2 times I1. We have to take the relationship. Intensity level, how much? Intensity level is what the human ears or the all animals detect the sound not by actually objective method. We call it the subjective. That the unit of the intensity. Intensity is nothing but energy radiated per second per unit area. Energy by time itself is power, which is equals to power by area. This one we have discussed already even for the light also in the wave theory of light. Intensity equal to power by area we can use. So units of the intensity will be watt per square meters. But intensity level unit is Bell. SI unit of intensity level is Bell. BEL, Bell. Capital B we have to use a symbol. And practical units we use is decibels. Decibels. So intensity level unit. Symbols I take it as intensity level as IL. Unit is decibels. Now we are calculating in terms of the decibels. Deci means 1 by 10th of a bell. This is nothing but equal to 1 by 10th of a bell. Is a unit of sound. Our intensity level, we notice our eardrum in terms of logarithmic scales. So log only we are taking the intensity level. Intensity level is compared means how much intensity of the other one compared to the other one sound with respect to other sound, that is called as intensity level. So intensity level difference, this don't bother about this part please, this one you have to take. Intensity level is nothing but equal to 10 log I2 by I1. This is a formula you have to remember. If we are given the pressure relation, means the pressure relation in terms of the logarithm scale is 20 log comes P2 by P1. But intensity level is nothing but intensity level is 10 log I2 by I1. This means it is logarithm scale please. Intensity level is doubled I2 by I1. Intensity is doubled. Whenever the intensity is doubled, one sound is having the intensity with the instruments measured is 2 times that other intensity. Then 2 I1 by I1 cancels, log 2 you will get. Log with 2 base not mentioned is base 10 place. So intensity level becomes equal to 10 log 2. Log 2 is 0.3010 into 10, it becomes equal to 3. That means intensity level increases by 3 times. That means if the intensity is doubled, our eardrum feels that it increases by 3 times. And 0 decibel, starting intensity is nothing but equal to audible range. Audible frequency of the eardrum, human ears, is 20 Hertz, approximately equal to 20 kilohertz. More than 20 kilohertz is called as ultrasounds, less than 20 hertz is called as infrasounds. Human adults cannot hear these frequencies. Infant, children's, and some animals can detect the ultrasounds and infrasounds. Sources you just go through the synopsis. Sources and animals they can detect. And this is related to the frequency range. But intense range, if you take intense level, is equal to 0 decibels starting point. 0 decibels is not actually a zero sound. 0 decibels is the intense level at which the sensitivity to the eardrum starts hearing. But as the age increases, the intense level changes. 0 decibels, even low frequencies like 220, 30, 40 hertz also we cannot hear properly. So intense level in the general case we take is starting of the audibility starts from 0 decibels. 0 decibels is 10 to the power of minus 12. 0 decibels is equal to 10 to the power of minus 12 watt per square meter. This is the intensity. This is the intense level relationship. So when you have to compare the intensity levels, you have to take the help of the log scales. Next, two sound waves intensity are given in the ratio I1 by I2 equal to 9:1 they have given. They asked you to find out what is the ratio of the maximum amplitude and the minimum amplitude. Maximum amplitude is nothing but equal to A1 plus A2, minimum amplitude is A1 minus A2. If they ask the maximum intensity, A maximum by A minimum square you have to take. Now intensity is intensely proportional to square of the amplitude. I1 by I2 equal to A1 by I2 square. So A1 by A2 is root of I1 by I2, that means root of 9 you will get is equal to 3:1 you will have. So A1 is 3 units, A2 is 1 unit you will have, and A maximum by A minimum we have to find out. Not divisible means same ratio equal to values we can take. So A1 plus A2 by A1 minus A2 is 3 plus 1 by 3 minus 1 is 4 by 2. Answer is 4 by 2. The answer is given as 4:2. Which is equals to 2:1. Next 146, these are organ pipes or closed pipe, open pipes. Closed pipe first overtone is equals to open pipe first overtone they mentioned. What is the ratio of the closed pipe to open pipe? Length you have to find out, length ratios. Open pipe frequency ratio is 1:2:3, same as that strings, vibrating strings. And open end always antinode is formed, closed end always node is formed. Fundamental frequency for the open pipe, if you have taken when the sound waves they go and reflect backwards, at the open ends you will find the antinodes, and here get the node. This is a fundamental, the lowest value we are taking, lowest frequency. So length of the pipe, this is node to antinode is equals to lambda by 4. So lambda by 4 to lambda by 4 becomes equal to lambda by 2 is the length of the open pipe. This V equal to f lambda, so f naught equal to V by 2 lambda. 2 times LO is the fundamental frequency of the open pipe. For the closed pipe, fundamental frequency, this antinode to node is nothing but equal to lambda by 4. So L equal to lambda by 4, F equal to V by 4 times 4 LC you will have. V by 4 LC is the closed pipe fundamental frequency. The ratios, if you check up now, there is a waves passing now antinode to node is lambda by 4, lambda by 4, lambda by 4. Like that you take the relations. That similarly for here, lambda by 4, lambda by 4, lambda by 4. Next lambda will be next length will be equal to 3 lambda by 4. You will get here you will get as equals to lambda by 4, lambda by 4, 1, 2, 3, 4. 4 times lambda by 4 is nothing but equal to lambda. You will get the next resulting frequency. This is the next resultant frequency for the closed pipe. Like that you will get the ratios for the open pipe 1, 2, 3, 4. Whereas a closed pipe you will have 1, 3, 5, 7. These are called as harmonics. All harmonics are present in the open pipe. Ratio is important here. And fundamental, this is the second harmonic, third harmonic, fourth harmonic. Other than fundamental, this is the lowest frequency. And other than the fundamental, next one you have to take it as a overtones. This is going to be first overtone and second overtone. This is going to be third overtone onwards. Leaving the fundamental, remaining all starts with the overtone numbers. Similarly for closed pipe, the ratio you will get is 1, 3, 5. First one is 1, next you will get a 3, next you will get the 5 times lambda by 4 and so on. So the ratio of the frequency, if you take 1, 3, 5, 7 odd multiples of a fundamental frequency, this is a fundamental frequency. Here any difference of the two frequencies will give the fundamental. Here not like that, please. Odd multiples you have to take, check up the carefully. So for removing the fundamental, remaining are called as a overtones. But all harmonics are not present. Whatever number is there is a harmonic number. Fundamental, first harmonic, third harmonic, fifth harmonic, seventh harmonic, ninth harmonic. This is a fundamental, also first harmonic. This is going to be third harmonic and first overtone. Leaving the fundamental, remaining overtone starts from 1, 2, 3, 4 onwards. This is the second overtone onwards. So first, what is the question told is, first overtone of the pipe is open pipe is equals to first overtone open pipe equals to first overtone of the closed pipe, they were told in the question. So for this first overtone is nothing but equal to for the open pipe first overtone is a second harmonic. So 2 times fundamental we have to take it. For the closed pipe it is going to be the third harmonic. The third harmonic you will get, that is going to be the first overtone. So 3 times F closed you have to get. Open pipe is V by 2 times LO, closed pipe is V by 4 times LC. VV same here, cancel the velocity of the sound V and you will get the expression 2 cancels 1 by LO equal to 3 times LO by LC by LO. They asked it is the order you have to check up in the question only. Closed to open they asked. So closed by open ratio is 3:4. Careful with the ratio of the questions they asked. Next is open pipe. Next 147. Open pipe frequency is F1. Okay, this is for the LO, open pipe length. Closed pipe frequency is F2 for the LC as closed pipe length. What the question is, the pipe is kept in the water such that 2/3 of the pipe is in the water. Whenever the 2/3 of the pipe is in the water, this is 2/3 of pipe is in the water, remaining pipe length is nothing but equal to 1/3 remains. So closed pipe length becomes equal to 1/3 of the open pipe length, that is in the air now. This is the condition take place. This is the fundamental conditions we are discussing. Frequency for the open pipe is V by LO equal to F1 they mentioned. For closed pipe is V by L 4 times LC equal to F2. And we equate both the cases and get the expression for F1 by F2 is equals to 2 by 3. Next level 2, this is standing wave equations. I just give you the hint here. Wave equation is given as 4 sine cos kx sin omega t. It is in the form of A. These are 2A. Two waves are combined. In the case of standing waves, we have the 2 waves combined. This is nothing but equal to A and A. Total amplitude is 2A. 2A cos function. If they give the cos, this is cos is a resultant amplitude function, this is sine function mentioned. Sine function starts from the 0 point node, cos function starts from the antinode points. So this is a 2A into cos kx sin omega t is the standard equation for the standing waves, also called as the stationary waves. In the comparison we have to take it up. 2A is supposed to be equal to 4. So amplitude we can find out from that as a 2 units. Whatever the units are given, centimeter means centimeters, meters means meters. Kx, k equal to 2 pi by lambda into x is supposed to be pi x by 3. And omega t, omega is 2 pi f or 2 pi by t is equals to 40 pi t. Comparison you have to take up and find out what they asked. They may be asking you in reverse also. This can be sin kx cos omega t also. That means the way we starting instead of the node may be taken from the antinodes. For the open end always node, free end is antinode. This open end or free ends are antinodes, closed ends are in between possible to have the nodes. Next is end corrections. End correction means due to the inertia of the air particles, the sound waves which is reflected backwards do not form the perfect antinode this open end, they form little above the open end. So antinode is formed here, not just at the open end of the pipe, little above into the air. How much distance above going depends on the diameter of the pipe, means mass of the air molecules. More mass, more inertia goes away. So the end correction value is 0.37 times the diameter of the open pipe. For the one side open pipe called as a closed pipe, this is the length of the closed pipe plus end correction is supposed to be equal to lambda by 4. Antinode to node is lambda by 4. So V equal to f lambda, from that you can get the frequency formulas. Generally we avoid this end correction, approximately we take the problems. Why? Because narrow pipes you have taken end correction very small and neglected, or you take the difference of two readings, you will get the elimination of the end corrections. If you take the open pipes both ends, end correction is two sides will be there. So LO plus 2E is supposed to be equal to lambda by 2 if the pipe is open at both ends. Next is resonating air column experiment. In the case of resonating air column experiment, a pipe is kept with the rubber pipe connected to the side reservoir, water reservoir. If you move the reservoir up, the level in this side pipe also increases. If the reservoir move down, the length in the side pipe also decreases. You can take water or any liquid, doesn't matter. What is important is the reflecting surface of the sound is required. A tuning fork of frequency N or F is kept at the open end, sound goes in and come back. When perfect antinode is formed here, you will find the resonance, air molecules are set to be in resonance with the frequency of the tuning fork, and you will find the loud booming sound is observed. Loud booming sound, you can hear that loud sound is heard here when the resonance of the air columns takes place, it's called. And that length plus LE, L1 plus E, length is the length of pi, can find with the help of the scale on the side. L1 plus E is supposed to be equal to lambda by 4. So L1 plus E is supposed to be equal to lambda by 4. This is called as L1 is called as the first resonating length. Next resonating length where you get is the first resonating length from the closed and open closed point you have taken, means this open side is nothing but equal to loud sound area. And next loud sound area is this value. Next loud sound is this 1 lambda by 4, 1, 2, 3 lambda by 4. Next 1, 2, 3, 4, 5 lambda by 4. You will get the open end. This open end, this is a closed end side. So you will get the order as 1 times, 3 times, 5 times. For the closed end, ratio is 1:3:5:7 like that. So next resonating pipe length, if you want to get same frequency you are taking, and length of the air column is increased. So water level is lowered. For that purpose, reservoir have to move it down. Then level will be equal in the reservoir and the side pipe always, because outside atmosphere pressure is equal. Now the length becomes equal to 3 times previous value. So this value you will get is equals to, this is L by 4, L by 4, L by 4, 3 L by 4. So this is going to be L2 we call it as length, resonating length. End correction L2 plus E. L2 plus E is supposed to be equal to 3 lambda by 4. And L2 minus L1 if you have taken, end correction is eliminated. End correction if you eliminate, you will get L2 minus L1 is equals to 3 lambda by 4 minus lambda by 4 is lambda by 2 you will get, or this lambda is equals to 2 times L2 minus L1, but we want the velocity of the sound will be asked. This is at T degree centigrade, room temperature, T degree centigrade. Vt is equals to 2n times lambda, means 2n into L2 minus L1. They will give you the two resonating lengths, and you will be asked to find the frequency or velocity of the sound. Okay, with this topic is completed. I will stop now.